and we will talk about more, like, I'm personally not a developer, like, let's wait for people to come. But by craft, I'm a DevOps engineer and SRE, so we will talk more about how to run your applications, what's fun with, like, what fun we actually had with PHP and all the work we did with running our applications in cloud, and we will discuss some lessons we learned all along the way with all the issues we had over the years. So I work with, in my company, I'm a co-founder of Labyrinth Labs. We are a one-stop shop for DevOps and cloud and Kubernetes for all around here, and yeah, Kubernetes. So we generally help our customers to move from, transfer their business and move to cloud and make sure that their applications can run and scale in cloud. So as I already said, by craft, I used to be a DevOps engineer. Now I mostly go to sales meetings and talk about being a good DevOps engineer and doing sales. So thanks for that. So generally, I would like to give you some intro, and maybe if you fall asleep, then next 2 slides are really important, and everything else is okay. So how to run PHP, why PHP is still relevant in this era and age, and what it means, and what the lessons are we learned, and then generally we would like to have some discussions. So I think what's really important is observability, what really we saw when we actually tried to run distributed and dynamic applications in cloud, and yeah, generally experience. Yeah. Sorry. Yeah. So some quick wins you can do right now, and I think it will help you run your application more efficiently and actually help you over time. So make sure that you have a good observability setup, so you understand and you can see what's really going on in your application. Sometimes when things go wrong, you generally will have to revert to manual tools. But yeah, like having a good observability is also important for like cost optimization. So making sure that you understand what you are paying for in cloud is one of the very, very important things, because once you start paying larger sums of money, your manager generally will come to you and ask like, why is this bill so high, and like I want it lower. And I think the second really important thing is that to understand that, like generally in cloud, optimal cloud costs are transitive property of good architecture. So if your application is well written, well architected, it generally will have lower costs than if you just put something together and run it. From our experience, PHP can scale, can run very well in a cloud native and Kubernetes setup, and we had very good experience with that. Okay, let's start. Like, is PHP cool enough to run in Kubernetes? What do you think? Like, raise your hand if you think PHP is cool enough. Oh yeah, yeah, it's cool enough for sure. So definitely, I think PHP, even if it's not really that popular these days, it has a robust ecosystem, has a lot of companies behind development of the language itself, so it doesn't depend on single company or a single VC-backed company. There is still a lot of new development happening in PHP, like JIT, fibers. So these are new features which are always like coming here, and the communities over time like onboarding them and putting them together. Also, it's much easier to find developers for PHP than for example, Rust. Like, Everyone likes Rust, but there are not that many of them. So for a company, I think going along with developing their backend in PHP is generally just fine. So from our point of view, and when we talk about cloud-native applications, there should be some sort of a definition. So cloud-native application is an application that can leverage cloud environment efficiently, and that means that it's scalable, it's resilient, it's distributed, it's observable, and generally that means it will run on Kubernetes, but that's not really a requirement there. You can run it on VMs, you can run it on other container orchestration systems, but in our sense, when I talk about it, it's generally always Kubernetes. So by scalable, I mean that you can actually scale to growing demand. So you can add more VMs, more pods, or more workload to handle more workload. And generally, I cannot really stress that enough, that scalable applications is really important. It's important for your costs, because you want to be able to save money if you don't really use that resources. And you want to make sure that you can actually utilize that. So from our own experience, PHP can run very well in containers, but there are some catches. One of them is like PHP, on contrary to Python or any other language, has quite a lot of configuration files you can actually deploy and manage for that particular version, and extensions. And managing that across multiple applications might be quite hard. Like when we initially started to work with PHP and migrate different PHP applications to cloud, we started with a simple Docker container or Docker file with different extensions for each application, and very quickly we find out that that doesn't scale. Like we had to maintain like multiple copies of the same Docker file with very little change in each of them. There were different versions of PHP, and the whole setup was basically a mess. And it took a while to us to actually make sure that it works for us and it doesn't take a lot of time. So managing the configuration is quite hard, and generally in PHP you have to do it. Like you have to configure the op cache size, you have to configure number of workers, and there are different settings you generally want to modify per application basis. Yeah, and one of the things which I know in PHP is not really a standard, like making sure you push your developers to have a regular security audits and security updates. So making sure that you don't really run 7.4 PHP in production anymore is when we initially came to them and tried to explain to the guys that like this is not really maintained anymore, like you cannot do that. There was a lot of pushback. Like they were like, "Oh man, like we don't have time. We need to build features." And we were like, "I understand, guys. This is not maintained. Like you have to upgrade." And so it's a sort of a tug of war where we push them to actually update and they push back. But like we are the way how I will explain it later. The way how we design the whole system makes it very easy to actually automatically upgrade the PHP versions. I talk page versions, not minor or major. So we generally do that in production every Monday, and it works very well. Yeah, and this is one of the really cool stories here. Like generally everyone who starts with PHP starts with engines and PHP FPM, and that's like a very easy to set up, very easy to run. But it has quite a lot of drawbacks. Like it's slow, like the performance might be better, but it's not very good. And once you look at the different alternatives, you can find like OpenSwoole, FrankenPHP, or a Roadrunner. Those are event-driven alternatives where you can migrate your PHP applications And we will talk about it also later, but there is a very significant improvement in performance, which actually means it's lowering your cost of cloud services and cloud build. Yeah, and we already spoke about it. Observability is a key, like understanding what's going on in your applications from metrics, logs, and traces is very often a key to better understanding like what you are paying for, what's happening, and how to actually maybe scale your applications before users or load comes. So generally, we tried maybe most of the options you can find around, and right now we are like migrating our whole metrics, logs, and traces to OpenTelemetry. If you don't really want to invest that amount of manual work into that, like you can use Sentry. They're very good. And so when we look at performance management, and I'm not really paid to say this, so don't worry. We use Tideways, and like we try different extensions, and none of them really work very well. And because we are using Swoole, they are the only extension which actually supports Swoole. So for us, it was not a brainer, and it works very well. So yeah, some technical details. So when we talk about like running PHP applications in Kubernetes, we always try to push our customers to make sure that their applications are stateless. They don't really have any context in file system or in container. And one of the reasons why it's really important for us to do so is that we generally want to move to use and run our workload on spot instances. And once you have something, if you store your data, if you store your files in a local file system, that generally really, you cannot really run that workload on spot instances. If we understand, and this is something which comes from business requirements, if we understand that the business needs to scale faster or lower, or there are huge spikes of users in a certain time, like we try to auto-scale the workload before. So we add more pods, we add more servers to workload before the users come. And that generally very well helps and helps us with any issues we can have. And yeah, application secrets. Most of the time when we start working with our customers, when you look at the applications, you have, I don't know, database passwords, database access keys everywhere around the source code, and having good hygiene there is, I think, really important from security point of view and from generally being a good developer too. And there are really nice ways how you can actually maintain that and keep that within your application. So one of the things what we learned is that keeping your pods within your Kubernetes cluster small really helps over time, because Kubernetes scheduler can put those pods together and run them on multiple servers and better utilize the server. You have much less waste within your servers, and that basically saves you money. You can actually do that with multiple ways, but generally you have to tune your requests and make sure that workers in PHP, FPM, or Swoole are set properly too. What is really important, if we talk about scaling and making sure that you can support workload or changing workload, is that you keep your startup time for your application at minimum. Like if it takes 15 minutes to start up your JBoss container, it's too bad. Like that's not gonna scale. So we actually invest quite a lot of time to make sure that we measure the amount of time it takes to start our application, and we invest quite a lot of time to make sure it's as low as possible. And one of the things which really, from our own experience, helped us is look at a good indicators for a performance issue in our application. So generally over time, like you can think that it might be latency, it might be this or that, But for every application, it's something different. But investing time and trying to understand like what might be those different indicators is really, really important. So don't worry, like we are coming to graphs, it's coming. So one of the things we really experience with PHP FPM is that, and it's because the way how PHP works is that sometimes if you have any issue within your infrastructure somewhere in the backend, most of the workers, all of them can get stuck. They cannot really execute any functions, they cannot really do anything. And this basically leads to cascading failures. And one of the interesting factors within our load saw that PHP applications can generate quite a lot of DNS requests. And I mean a lot. So this is per minute. It's 600,000. And we will have a graph here which talks about how many actually requests are coming to our servers. So it's around 18,000. So it's quite a lot of DNS requests for every single HTTP request which comes to our infrastructure. If you ask, like, why is it happening? One of the reasons is that for every request you have to resolve database, Redis, and S3 bucket, and multiple other SQS, SNS, every other endpoint you use within your application. And generally, both of them are done in IPv6 and IPv4 format. And so to actually handle this such a load, because when we initially run our applications in Kubernetes cluster, we've been able to basically kill any DNS server you find outside. Like we cannot really use anything public. So we had to implement infrastructure where we are caching the DNS request on a node. Then we have some second level cache, which is core DNS here, which is actually being hit with 3,000 requests per second, which is much less. And so we had to build an infrastructure to actually support this kind of a load on DNS. So PHP performance. So from our point of view, like PHP offers a good level of performance. We never really had anything problematic with that. One of the things we really learned is to push developers to cache everything and to do it very early and often to make sure that they don't necessarily hit the database every single time. They don't necessarily go to disk or go to Redis every single time. One of the interesting things was that initially when we started to migrate applications to this Kubernetes cluster, we did it like YOLO style. Like we moved the application, started it, ran it for a while, and it was working. And but we over time find out that it's much better to actually do a load test on your application to better understand the behavior, the patterns, because when you are moving from VMs to containers, the whole performance structure is different. Like the application itself will behave in a different way. Yeah, so this is really interesting thing. Like generally we started to use PHP FPM, and over time we moved to Swoole. And Swoole is an execution engine which enables you to continuously run either Symfony or Laravel engine within itself. And contrary to NGX and PHP FPM, where for every single request you have to create the Symfony engine, Symfony runtime, run and execute the request, and then you throw it away. With OpenSwoole, it's running all the time. And that basically saved us almost 70% of our compute resources we've been using. So generally from 100 nodes or servers, we've been able to run it in 30. So that's quite a lot. That's quite a big saving on our end, and it also helps with latency. I have graphs, so don't worry. There are also some troubles. Like first one is you have to make sure that your extensions are compatible and they're gonna work. Most of the time they work. Sometimes, for example, Xdebug has some issues with that. If I said before that one of the really strong suits of PHP is that there is a strong community behind, now you are introducing a new vendor there. Like this might be supported by one developer or a couple developers. If they leave, then you are stuck with unmaintained software and you have to think about it. And also you have to rewrite your applications to sort of support it. So it's not that hard. Like for us, it wasn't that really a challenge, but maybe in your case it is. So you have to think about it too. So this is a graph, and this is one of the, as I said before, SLEs, where we measure number of requests we can actually handle with one pod. And generally we started somewhere around 9. That's our baseline. I'm not sure if you see it properly, but we started here. That was around 9. And the first step here, where we moved to around 18 or 20, was where we actually moved to Swoole. That was the first and initial migration. And here we find out that, okay, that Swoole helped, but it didn't help in a way as much as we expected, and we started to look for reasons why. Like one of them, like we generally, when we really need to look deep down, we used strays and TCP dump, and we try to figure out like what's going on, profiling with Xdebug, and we find out that our application spend almost 80% of the time for each request just parsing the configuration files which were written in XML. And so we moved from XML to JSON, and this bump here, that's just moving from XML to JSON. And here, where we go to almost like 6 times higher than we started, that's where we implemented a proper caching of the configuration files, so we don't really read them for every single request. We started to cache them in APCU and locally within the PHP VM. And so basically that's where we ended at the end. So it's almost like 6 times better than what we started with. Yeah, and this is how the latency looks. These are like outages and spikes, don't really worry about them. So it's almost 2/3 lower. And this is P99, so this is the like the worst latency you can see. So one of the really interesting things when we initially did the migration was we actually had an issue with APCU cache. Like when we started to cache things in APCU, we did so many of the caches and requests that we actually triggered expunges on opcache and APCU, and we had to tune the APCU in a way that we not really allowed those because they were really killing our, there was an internal garbage collector which was really killing the application performance. So we more or less avoided that issue right now, but that's an interesting thing. Like even with very known and well-used extensions, you can find out that in some corner cases, it's really hard to run, and you have to think about really low-level details. One of the things which doesn't really work with PHP is workers. I mean, not really like FPM workers, but something where you have producer-consumer model, where you have a worker which is a standalone application, which is not receiving requests from web, but is running and it's reading messages from SQS and doing some work and doing something which is asynchronous. So generally, like you can always do it with PHP CLI, but it's not really good way, at least in our case, because it's always a single process, it's single thread. For us, it's really hard to gather metrics and logs because the PHP CLI cannot really open any ports, so it's we cannot really scrape the metrics from them. So we had to figure out a really cumbersome way how to fetch the metrics from them, and it's really hard to get the scaling right because the workers generally are either very busy or are not really doing anything at all. Like there is nothing in the middle. And to figure out how to really scale that, like we had to, we are still trying to do that in the right way. But our current approach is to look at number of messages in a queue and try to figure out if we have to add more workers or not. Yeah, and we talked about this before. So one of the things we experienced before, and we still do, is when we, and this was happening much more with PHP FPM than it's happening with our current setup. But with PHP FPM, when we had any issue with database, Redis, or any REST endpoint, which is somewhere behind, we tend to see a problem where most of our workers get stuck waiting on finishing the requests, and then the stuck workers keep piling on, and at the end of the day, like we couldn't really execute any requests, and not even those which are like liveness and readiness probes, which meant that most of our pods started to restart, and the whole thing went really south and very quickly. So generally, the way we deal with that is make sure we disable liveness and readiness probes and let it like go to timeouts and make sure that once the backend stabilize, like we can actually survive and we can get to normal function soon. So one of the interesting things is that we generally, when we started, is that we had a very small applications move to production first, and that was very easy, and we didn't really have any issues. But once we moved to bigger and bigger, it became exponentially harder to run that infrastructure because once you have 15,000 requests per second there coming, you have to look at every single thing and every single detail might be actually something which will affect the whole system, and you have to spend quite a lot of time figuring out like what's going on and what went wrong. Yeah, I try to maybe show how many servers do we run in a given time, but this is over, I don't know, 20 days, and don't really pay attention to these spikes. That's deployments. Those are deployments or some sort of events. But we generally run around 150 to something around 70 servers. And over a period of day, like we scale up and then we scale down and we move around that. And those servers are all spot instances. Like we don't really run EC2 instances, on-demand instances, nothing else. Yeah, and this is number of requests. So when we have a peak or sort of an event, then we can hit somewhere around 18,000. And generally the mean is maybe 11. So one of the things we developed but never really released to open source, and we would like to, is base image container. So when, as I said before, like we had multiple applications running and maintaining different extensions and making sure that they work, and everything was quite pain in the ass for, I don't know, 15 or 20 services we run for this within Pixel Federation. So we tried to figure out a better way. And one of the things we addressed that issue is that we created one repository from which we build our different containers. So we have a base container which has support for like all extensions we need and are required for production. It's we make sure that it's really small. We make sure that there is support for everything we need, and also that we can actually configure everything we need with environmental variables. That's also something which we couldn't do initially, but like with our own model, we can do that. And also, which is what is really interesting, we built Intel and ARM version 2 because these days every developer has Mac and ARM. So we generally support every maintained version plus one which is ahead and one which is behind to make sure that our developers can actually move up and down. Yeah. If you don't really like S-trace and TCP-DUM, I think I have a bad message for you. Like, these are your friends and use them often. Like, very often when we have a real performance issue, we end up like S-tracing the workload and making sure we better understand what's going on, no matter how good observability is. Like, we almost always end up using these two tools. And one of the interesting things which we find is that when we started, like we used to save log files or logs into files, and that really caused us a lot of different issues within our system. Like the pods grew much bigger than we used to, and we wanted them to. And these days, like we print all the logs to std out, which generally in Kubernetes ends up in a file in a node, and we collect them from there. And it's much easier, and it keeps the pod and cache, file system cache in the pod clean. I think we are over time, but like generally, like we had a very bad experience with running WordPress applications in Kubernetes that doesn't really scale, and it's really, like, we had to do quite a lot of development to keep it working, but. So we try to avoid that, but I would like to hear more about like if you do that, like how to do that properly. Yeah, do we have any questions?
Perfect, thank you. We have questions. So I will start with the first one. When should a multi-client software house adopt Kubernetes? What minimal criteria make it a good fit? And when does it not make any sense? It actually interests more people. So, like, what's your opinion on that? Like, what is the state of of the case where it makes sense and when it doesn't?
I think generally, like from our point of view, but that generally, like we like Kubernetes. That's why it most of the time makes a lot of sense. But if you want to have one platform you can use across cloud providers, if you want to have one interface you can operate, I think Kubernetes is a very good option for that. These days you have operators and automation around Kubernetes built to maintain databases, to maintain like infrastructure, and all sort of way. And it's sort of becoming a general trend and like industry standard. So this way I think it's generally very, very much okay to run it all the time. And you can isolate your clients, you can make sure that the tenants doesn't affect each other. So for me, it's generally okay
Always. Yeah. Maybe the question was more like if I'm just interpreting it, like imagine the minimal possible project that or code base that it makes sense, or not a code base, but maybe.
So if your project runs on one VM, I think you don't use Kubernetes for that. And but if you have like 20 customers and each of them is using one VM, I think that's a good case for Kubernetes, because you can put it together. You can have scheduler automated in a way that it's quite efficient, and you can have database outside of Kubernetes that's going to work fine.
Okay, I hope we answered that. Okay, what do you think about Franken PHP?
So we don't really have any experience with that. Like we used Swoole, that was like a first execution engine, and Franken PHP came later. Like we are looking at it, but we don't really have any experience with that.
Okay. What is the right time to migrate an app to cloud? Would you recommend having an app in cloud from beginning, or just go with the VPS and migrate to cloud later, maybe as it scales or something?
Yeah, I think one of the ways how you can look at it, if you are not already in cloud, you can move then once you feel you are about to scale. Like once you, I don't know, you get investment or you find your product market fit, I think that would be a good time to actually move there to make sure that you can handle users and your scale.
Okay, thank you. Has moving to Swoole caused some data leaks since the app isn't stripped down every time? What should we watch for?
No, like we haven't had any data leaks, but we had some issues and we had some outages because of that. But that's something I think it's expectable. So if you need any consultation or any help, I think I can connect you with programmers who actually manage the migration to Swoole in Pixel Federation, and you can talk to them. But generally, from our point of view as a SRE and DevOps engineers, like we haven't had any issues caused by just Swoole. Like maybe other things were involved too.
I'm not sure if I understand it correctly, but maybe the last question is like asking pretty much the same, right? Help me with that, maybe, Adam. Okay, so maybe let's look at the different one. What is your most and least favorite thing about Kubernetes?
Yeah, so I think the most is the community and the whole ecosystem, which is really interesting. And the least favorite is the updates. Yeah, that's for sure. There is quite a lot of updates with Kubernetes. You have to do it once in, I don't know, 6 months.
Okay, thank you very much, Adam, for your insights.